Now we are defining the LCM and HCF for all these tests given in the above. Suppose we are finding the LCM between 18, 30 and 45. And you have to find out the LCM of this simplest numbers there. So we can use like this. We can write this method 18, 30, 45. You will start from the prime number 2. It is 2, 15, 45 as it is, which is not divisible. So you have to write as it is for that number. Then this number is 3, 5 and 15. Then again by 3. Then it is by 5. And then it is by 3. So LCM of these simplest number are equal to 2 into 3 into 3 into 3 into 5. So that thing is equal to 2 5s are 10 or 3 3s are 9. 27 into 10, 270 is the LCM of these simplest numbers there. Now you have to find out the LCM of decimal numbers. For example, 3.5, 5.4 and 7.2. These are the three decimal numbers there for which you are finding the LCM of these three numbers. First of all, we will change all these numbers in the form of the fraction. And then you will find out the LCM of this 35, 54 and 72. This 2, 35, 27, 36. Then by 2, it is 35, 27, 80. Then it is by 2, 35, 27 and 9. Then you can divide it by 3, 35, 9, 3. Then you can divide it by 3, 35, 3, 1. Then you can divide it by 3, 35, 1, 1. Then you can divide it by 5, 7s are, and then you can divide it by 7. So LCM of this numerator terms is 2 into 2 into 2 into 3 into 3 into 3 into 5 into 7. This number is going to be 8, 27 and 35. This is equal to LCM of denominator is basically 10. So final LCM is 7560 divided by 10, that is equal to 756 is the LCM of these numbers there. Then we can find out the HCF of the numbers. We are now finding the third example of this case. Find the LCM of these fractional numbers 2 by 5, 7 by 6 and 8 by 9. The formula for this portion is LCM of more than 2 or more than 2 fractions is equal to LCM of numerator divided by HCF of denominator. So we will use this formula for this part. We know that the numerators are 2, 7, 8. So LCM of 2, 7, 8. 2 ones are 2, 7 as it is 4. Then 2 as it is 1, 7, 2. And then 2 as it is 1, 7, 1. And then 7 as it is 1, 1, 1. So LCM of numerator is 2 into 2 into 2 into 7, which is equal to 56. So for this answer, the LCM of the numerator there is 56 divided by the HCF of denominator. So 5, 6, and 9, you are going to find out the HCF of these three numbers. So we can use this 9 divided by 6. It is 6, 3, then 3 is taken outside. Then it is 6 there, 3 2s are 6. So HCF is 3. So you can divide it now 5, 3 ones are 3, 2, then by 3, 2 ones are 2, then 1, 1 twos are 2. So 1 is the HCF of this portion there. So the whole answer is 56. Now we are finding the HCF of simplest number. Suppose you are going to find out the HCF of 50, 70, and 80. So you can use this one method. 50 is equal to making the prime factors 2 into 5 into 5. Then 70 will become 2 into 5 into 7. Then 80 will become 2 into 2. Now you will find the common element because HCF stands for the highest common factor. So which is common in all these three? This 2 is common in all these three. This 5, this 5, and this 5 is common in all these three. This 5 is here, but not here, so it will not be taken. 7 is not there. So the HCF of this is equal to 2 into 5, that is equal to 10. Or you can use other method there. Select one number and divide it by other. Then 20 is taken outside, 50 will be taken inside. 22s are 40, 10, then 20 is inside. So 10 is the HCF of 50 and 70. Then use this 10 for the rest of the third number there, which is 80. So again, 10 is going to divide this 80 there. So the HCF of this factor is also 10 there. So this is when you use the common things, the common factors in all these three parts or four parts. And we are going to find out the HCF of these. But if HCF of fractions is going to be taken, HCF of fractions, then it should be equal to HCF of numerator divided by LCM of denominator. So this is the formula we are going to use for this portion there. Now, let's say the fractions are 5/8, 7/6, 10/15. So, by using this formula there, HCF of this whole fraction is equal to HCF of numerator. And numerators are 5, 7, and 10. So, you can use this because 5 is prime number, 7 is a prime number, 10 is a prime number. So when there's only one number there which can divide all these three, and that is equal to 1. So HCF of this 5, 7, and 10, that is equal to 1 there. Now we use the LCM of denominator. Denominator has 8, 6, 15. So it is 2 4s are 8, 15 as it is, then by 2, then again by 2, then by 3, then by 5. So 2 4s are 8, 3s are 24, 5s are 120. So the HCF of these three fractions is equal to 1/120. For two numbers, let's say one number is equal to X and the other number is equal to Y. The rule is the product of two numbers is equal to LCM of both and HCF of both. So this is the rule which are being used in this part there. Let's say the HCF of this is given to you equal to 34. LCM of these two numbers is equal to 4284. One number, let's say that is equal to X, and that thing is equal to 204, and you are going to find out the other number there. So we can use this formula. The product of two numbers is equal to LCM into HCF. So one number is 204 into X, so into Y, and that thing is equal to LCM of these number is 4284 into 34. So Y is equal to 4284 into 34 over 204. So Y is equal to be 714. So the other number is there equal to Y, which is equal to 714. So these are the few theories about this LCM and HCF of the numbers which will be used in your test for the SAT GAT GRE GMAT. And in the assignment, we will use all these tips for the calculation of the numbers there.